Welcome to Engineering Visualization channel. So today we are going to discuss about scales. Okay, scale is a device which is used to measure any kind of objects which are having various sizes. Okay, it is a device which is used to measure any kind of sizes. You can see, so there are different types of scales over there with a different gradation, and they'll be used for different kinds of engineering works. Okay. So types of scales, you can see here basically we have two types of scale: engineering scale and graphical scale. So engineering scale we have full scale, enlarging scale, reducing scale, plane scale, diagonal scale, vernier scale, comparative scale, and scale of chords. So here a full scale means here if any kind of drawings were drawn to the exact size, we call that as full scale. If the dimension of an object is very less, so we need to enlarge, like components of a wristwatch which is having very minute components, so needs to be enlarged. Okay, the same way reducing scale means here the dimensions of a buildings, bridges needs to be reduced, so in those cases we are going for the reducing scale. Okay, so based on the requirement we will be selecting the full scale, enlarging or reducing. So in the full scale, either if the dimensions were of very less, say 30 mm diameter circle has to be drawn, means same way. So representative factor. Okay, now as we have seen enlarging or reducing scale, so here this representative fraction plays a very important role here. So by multiplying this representative fraction with the actual length of the scale, so length of the element in the drawing we can able to find out. So we can able to reduce it also, we can able to enlarge it also by multiplying this representative fraction. So this is a very important aspect. Okay, using this representative fraction we can able to enlarge or reduce, or we can able to draw with respect to the actual scale of the drawing. Okay, and the same thing we see in the type of scale. Okay, in the case of full scale it is 1:1. If it is enlargement scale means here the maximum size is to 1. Reducing scale means 1 is to the reducing scale. Okay, in the same case it is recommended in the BIS standard. You can see full scale 1:1, reducing scale 1:2, 1:5, 1:10, and enlargement scale. So the first we write the bigger number, and then the is to 1 we write 50:1, 20:1, like that. So what are the important things we require for construction of scales in engineering drawing is, so as we have to identify whether we are drawing for using plane, diagonal or vernier, and the representative factor, and the maximum length of the can be measured from the scale, or minimum length can be measured with the scale, that is least count, and then with the multiplication of representative factor, so length of the scale can be easily find out using a particular formula. So here we see the types of scales here now: plane scale, diagonal scale, vernier scale, comparative scale, and scale of chords. So plane scale here basically it is used to find out two consecutive units. Okay, example like meter and decimeter, or it can be feet and inches. So in those cases this plane scale is suitable. Okay, where we require only two consecutive units to be measured. Okay, with the immediate subdivision. But this diagonal scale, it is having a little bit higher standard compared to the plane scale. So here we can go for the three consecutive units. Okay, you can see that is meter, decimeter, and centimeter. So diagonal scale gives the more precision compared to the accurate or precision compared to the planar scale. So vernier scale here it is usually it is also to measure the three consecutive units, and here and it is in metric scale. Okay, so here basically it consists of two kinds of scales here. One is main scale and vernier scale. With the help of this main scale and vernier scale we can able to find out most precision dimensions. Okay, so it is basically used in vernier calipers, screw gauges, and micrometers. Okay, so it can be used there. Comparative scale means here the different dimensions of a in a map we can able to measure parallelly both kilometers and hectometers by using in a comparative scale by the representative factor, okay, like miles and furlongs. Scale of chords basically used where we want to find out the angle where we don't have the protractor. So it is basically used to find out the angles, okay, angles you can able to measure or set any angles using this set of chords. Okay, so that completes the topic. Okay, so you can subscribe for the channel and hit on the bell icon for the latest notifications and share it to the maximum students so that they can be benefited. Thank you all. Thank you for watching the video. Representative factor. So if the actual length of the object is 50 feet, so using representative factor we can reduce it to get the actual length of the diagram. So actual length of the diagram is different and actual length of the object is different. You can see in the example 50 feet of the actual length of the object using representative factor of 1 by 25, you can get actual length of the diagram is 2 feet. The same thing here we represented by means of a simple formula. RF is equal to LOD by actual length of the object. Important parameters to be considered for learning scale. So there are 6 important parameters. One is size, representative factor, units, types of scales, and maximum length of the object and length of the scale. You can see in the sizes we have 3 types of size: full size, reducing scale, and enlarged scale. So using representative factor we can able to reduce the maximum size into the required size, and we can enlarge the minute size into the actual scale, and then using the different types of units we can able to do the conversions. And then different types of scales were used based on the requirement, like plane scale, diagonal scale, comparative scale, vernier scale, and scalar scale. And Lmax is nothing but maximum length of the object we should consider when we drawing it. Okay, so length of the scale is nothing but it is the reduced scale. You can see therein we have used the RF, nothing but representative factor, wherein we can use the maximum length of the object. So there are some cases we can use the maximum length of the objects. In some cases we consider the based on the requirement we can choose the length here. So these are the important factors we should consider before we start learning the scale. So each of these things we should be clearly understand. You can see RF, using RF factor we are getting different values. Say if we are using the full scale, the RF factor is RF is equal to 1. If you are using a reducing scale, so RF factor should be less than 1. If you are using a enlarging scale, the RF factor greater than 1. So like this we should use it. Units. Here we have 3 types of measurements. One is linear measurement, square measurement, and MKS or FPS system. You can see in the linear measurement we have 10 cm is equal to 1 cm, 10 cm is equal to 1 decimeter, 10 decimeter is equal to 1 meter, like that. The same way in square measurement we have 100 mm square is equal to 1 centimeter square, 100 centimeter is equal to 1 decimeter square, 100 decimeter square is equal to 1 meter square, and 100 meter square is equal to 1 acre, and 100 acre is equal to 1 hectare, 100 hectare is equal to 1 kilometer square. In the same way in MKS or FPS system we have 25 mm is equal to approximately equal to 1 inch, and 12 inch is equal to 1 foot, and 3 feet is equal to 1 yard, 220 yard is equal to 1 furlong, 8 furlong is equal to 1 mile. So you want to see the conversion of each of these. Say 1 meter is equal to how much mm means, you just see that 1 mm is equal to 1 meter is equal to 10 to the power of 3 mm here. So we need to go with respect to the 3 rows here. Okay, in the same way 1 kilometer is equal to 1 2 3 4 5 6, so 10 to the power of 6 mm. In the same way you can see with respect to the 1 yard here. 1 yard is equal to 3 into 12 into 25 mm. Okay, in the same way you can find it for 1 meter square is equal to how much mm square. Here it is 100 into 10 to the power of 3 mm square. So like this we will find out the conversion of the units. Okay, so conversion of the units is very important here. So how much centimeters are equal, how much mm, how much one decimeter is equal to how 100, how much centimeter, we can able to find out from this. Thank you all.